Here we have a SAT math problem. Okay, let's go to the question. In the xy plane above, the area of square ABCD is equal to the area of triangle CDP. What is the value of A? Okay, here we have the square that is ABCD, and the area of this square is equal to the area of this triangle CDP, and we have to get the value of the constant A, which is being as the x-coordinate at the vertex of the triangle P. Now let's consider the two vertices of the square A and B. Okay, here using these two vertices, I'll be able to get the length of the side of the square AB. So for that, we have to consider the y coordinates over here and here. So what is the distance from 4 to 10? So that is 6. So 6 is the length of the side of the square AB. We know that in a square, all the four sides are equal. Then the length of the side CD also 6. Then the length of the side BC also 6. And then the length of the side AD also 6. And also, we know the formula to get area of a square. That is side times side. That is 6 times 6 is 36 square units. Okay, here I got the area of the square, 36 square units. Okay, so we know that the area of a square ABCD and the area of the triangle CDP are equal. Okay, now what we have to do is we have to get the area of this triangle CDP, and we can equate that area to 36, which is the area of square. So using that equation, we'll be able to solve for the constant A. Okay, for that, what we need to do is we have to use a formula to get area of a triangle, 1/2 times base times height. Okay, here we can consider the side CD of the triangle as base, because we know the length of this line segment CD. So we can consider the CD as the base. Then how do we have to get the height of the triangle? For that, let me extend the base of the triangle CD to x-axis over here. Since it's a vertical line over here, when we extend this one, so it will form right angle over here. Now let's consider the line segment we have over here. So it's a perpendicular line drawn from the vertex P of the triangle to the base of the triangle over here. Since it's a perpendicular line from the vertex P to the base of the triangle, we can consider this one as a height of the triangle. So the length of this line segment is height of the triangle. Already we have the base, that is 6. Okay, how do you have to get the length of this line segment, which is being as height of the triangle? For that, we can consider the length of the side of the square AD. So that is 6. And here at point A, we know that the x-coordinate is a -3. So here we have y-axis. What is the length of this line segment? Since the x-coordinate over here is -3, the length of this line segment is 3. Then what should be the length of the line segment over here? This one also must be 3. So that the length of the side of the square AD has to be 6. Okay, so when the length of this line segment over here is 3, what should be the x-coordinate over here at the point D? Then it has to be 3. And what is the y-coordinate? Already we have y-coordinate 4 over here at the point A. So we have the value 4 on the y-axis over here. So the same 4 we have as y-coordinate at the point D. Okay, now let's mark the value on the x-axis corresponding to this point D. Since the x-coordinate over here is 3, then we'll have the value 3 on the x-axis over here corresponding to this point D. Okay, now to get the length of this line segment, we have to get the distance from this point, that is from 3 to this point. Actually, the x-coordinate at this point is A, so we have the value A over here. So how do you have to get the distance from 3 to A? For that, we have to subtract the smaller value from the bigger value. Clearly, 3 is a smaller value and A is a bigger value. When I subtract 3 from A, I am getting A -3. So this is the length of this line segment, which is being as the height of the triangle. Okay, here I got the height of the triangle, that is A -3. Already we have the base of the triangle, that is CD. Its length is 6. Okay, now let's get the area of the triangle CDP, that is 1/2 times base times base is 6 and height is A -3. So this is the area of the triangle CDP over here. So the area of this triangle CDP is equal to the area of the square ABCD over here according to the question. Already we have the area of the square, that is 36. So the area of the triangle CDP equals to area of the square 36. Now we have to solve for A in this equation. Okay, here 2 goes into 2 1 times and 2 goes into 6 3 times. 1 times 3 is 3. We get 3 times A -3 on the left side. On the right side, we have 36. Okay, now let me divide both sides of this equation by 3. Then this 3 will cancel out. I'm getting A -3 on the left side. When I divide 36 by 3, I'm getting 12. Let me add 3 to both sides. When I add 3 to both sides, -3 +3 will cancel out. I'm getting A equals to, when I add 12 and 3, I'm getting 15. Okay, here I got the value of the constant A. The value of A is 15.